Good evening, everyone. Today we're going to be talking about shrinking versus stretching in transformations of graphs. So, there are several types of transformations that we will not be going over in this video. We will be going over shrinking and stretching, however. So, whenever we have a graph of y equals to something in terms of x, for example, y equals to x squared, y equals to x cubed, for example, y equals to 5 over x, for example. What we should always have in mind is the points of x versus y in this format, because by plotting points for x and y into the equation, we can always be able to graph. So right now, let's start with the first type of transformation, shrinking. So we have here a classic y equals x squared graph with points such as 2 hitting points such as 4. So 2, 4 is a classic point. 1 and 1, classic point, and so on. And it's the exact same here. Okay, so the first type of transformation here is shrinking. So from its name, shrinking, when we say shrinking, we are expecting the graph to stop looking like U in a sense and start looking more narrow, something like this. Why does this happen? So when we have a narrow graph like that, we are expecting y to be increasing at a rate that is much faster than x. If you look in this direction or this direction, and then this direction that is perpendicular to it, y is increasing or decreasing in the case of a negative parabola at a rate that is much faster than x is increasing. So why does this happen? Let's go behind the math. So in this case, our example is going to be y equals to 2x squared, and that will be our example. Okay, there we go. Why did I pick y equals to x squared? So the conditions for shrinking to occur is that we will have a coefficient next to x that is multiplied by x that has to be greater than 1. So if the first condition is if the coefficient is greater than 1, then the graph is obviously going to be increasing faster in the y direction than it is going to be in the x direction. So let's plot the points and see how our graphs going to look like. So I usually use a classic 5 points, -1, 0, 1, 2, and 3 to graph my points. I'm sorry, yeah. So at -1, in the classical equation, y equals x squared, this would be 1. This would be 0, this would be 1, this would be 2, and this would be 3. Sorry, this would be 2, this would be 4, and this would be 4, and 9. Sorry, but 4, and this would be 9. This would be in the okay. Now let's go back to this format. Now here, if x equals to negative, we're going to have y equals to 2, -1 squared. This is going to result in 2. This is going to result in 0. This is going to result in 2. This is going to result in 8. And this will result in 18. So as you can tell, those values are much bigger than those values with the origin staying the same, which is what we want, obviously. So this type of transformation will be only like this with the origin staying the same. Also, shrinking. Shrinking is the exact opposite of what we just did. And for the conditions that we have to meet, the coefficient has to be less than 1. So when the coefficient is less than 1, such as in this example, according to our math, the x is going to be increasing much faster than the y because of this diminishing factor. So let's look at it. Let's look at the numbers in the classical points. Here we go. 2, and then 3, and then x squared is definitely going to be 1, 0, 1, 4, and 9. And this is going to look like this. Y equals to 1 over 4 negative 1 squared. That's going to be 1 over 4. It's going to be 0. That's going to be 1 over 4. And then 2 is going to be 1 over 4. 2 squared. That's going to be 1. We finally reached 1 at 2. You can see. And then 3 is going to be 9 over 4. So as you can tell, this graph is not really going up as much in the y direction, and will therefore be much thicker in a way. So that's the difference between stretching and shrinking. All right, so now let's try solving an example where we apply what we just learned. So this question says transform the graph of y equals x squared, this graph, the parabola, by shrinking it by a factor of 6. So now, they said the word shrinking. I'm going to go back to my knowledge, stretching versus shrinking. Stretching is coefficient is less than 1, shrinking is coefficient is greater than 1. So that means our two options are 6 or 1 over 6, since it says factor by 6, it's a factor of 6. So since it's shrinking, I'm going to go ahead and pick the one that is greater than 1. So now I know that my equation is going to be y equals to 6x squared. Now using that, I'm going to plot my points using the classical numbers. So negative 1 is going to be 6, 0, 6. Then this is going to be 24, and this is going to be 54. And now, as you can see, y is increasing much faster than x is, much faster. So this graph is definitely going to look like something like this. And obviously, since you have the points, you can be accurate with the graphing. So you can go from 1 to 6 and graph that as a point, and so on. And thank you for watching, and see you next time.